Hey everyone, welcome back. So today we are diving deep into some really thought-provoking stuff.
Yeah, this should be interesting.
Absolutely. It's from this paper actually called True or Fantasy 2 for Podcast.txt.
Oh, I think I saw that one, yeah.
Yeah. And it questions like the very foundation of math.
Whoa, big topic.
Right. Like how much can we actually rely on math?
Yeah.
What are its limitations? And then taking that a step further, how does that impact science, which, as we all know, relies heavily on math?
Right. It gets you thinking.
It really does. And the author of this piece, they have a really, I don't know, it's almost like a conversational tone, even though it's about super complex ideas.
Yeah, I noticed that too. Very engaging.
Yeah. And one of the first things that just stopped me in my tracks was this whole thing about big symbols, they call them.
Big symbols.
So try to imagine this. A number so unbelievably huge that even if you could write out each digit, like tiny, small enough to fit inside a single atom, it would still be too big to fit in our entire galaxy.
Wow. That's kind of hard to wrap your head around.
I know, right? It's like, whoa.
Definitely makes you think about the limitations of numbers and how we even try to represent them.
Exactly. And, that leads right into the author's main point, which is some of these core math concepts, like infinity.
Oh, yeah. Infinity. Always a tricky one.
Right. Or irrational numbers, like pi.
Mm-hmm.
They argue that these things, they might not be as well defined as we think they are.
It's interesting because, think about pi. It has infinite decimal places that never repeat. How do you even begin to grasp that concept, infinity, when we can't actually, write it all out, represent it fully?
It's like our brains just kind of short circuit,
Yeah, it's beyond our comprehension in a way.
And, it made me think, if we're struggling to even define these basic, supposedly basic concepts, what does that mean for the rest of math? And this is where the author takes this whole thing to a whole other level, because they're like, okay, so math has these limitations, but science is based on math.
That's a big statement.
It is. And it made me wonder, how much can we really trust science to be accurate if it's using something that's, potentially flawed?
It's a good point. I mean, when we talk about science being exact, we're talking about its ability to predict and describe the world around us, right? But no model, no matter how good it is, can perfectly represent reality.
Right. Even with something we use every day, like weather forecasts.
Exactly. Think about it. We have supercomputers and complex algorithms, but can they tell us exactly what the weather will be like down to the minute, weeks in advance?
Definitely not.
No. There are always variables we can't fully predict or measure.
So it's even in something as familiar as, checking the weather app, there's that element of uncertainty.
There is. And that ties back to what the author's saying about math and how that uncertainty carries over into science.
And this is where, honestly, I started to get a little whoa, is everything I thought I knew wrong?
I think the point isn't to say that science is wrong, but rather that it's important to acknowledge its limitations.
Yeah, it's like being more upfront about the potential for error.
Exactly. Instead of saying this is an absolute fact, it's more like, here's what we know based on the best available evidence, and here's where there might be some uncertainty.
And I think that's actually more trustworthy, wouldn't you say? It feels more honest.
I agree. It invites skepticism and further investigation, which is at the heart of the scientific process.
And that actually brings us to the author's final point in this paper. And it's kind of a mind bender.
Lay it on me.
They're saying basically that nature itself, with all its complexity, is just indifferent to our attempts to box it in, define it with our human concepts.
You see what they're getting at.
We have this idea of a perfectly straight line in math. Does that actually exist in nature?
Not really. If you think about it, everything is curved or irregular on some level.
Right. So it begs the question, is math something we invented or something we discovered? If it's a tool we created to try and understand the world, how much is our understanding limited by that very tool?
That's a deep question, and I think the author leaves it open for us to ponder.
It does. And it really got me thinking about how we see the world. It's like we're looking through a special lens, And that lens, our math, our science, it only shows us a certain slice of reality. There might be a whole other dimension out there that we're just not equipped to see yet.
It's a fascinating thought, isn't it?
It really is. So in this deep dive, we've covered a lot of ground, right? We've questioned the foundations of math, the exactness of science, and even how we perceive reality itself.
Quite the journey.
It was. But the point isn't to create doubt, but rather to approach knowledge with a bit more humility, to recognize that there's always more to discover and maybe even entirely new ways of understanding the universe waiting to be found.
Absolutely. And that's what makes this deep dive so powerful.
Mhm.
It challenges us to expand our thinking and embrace the unknown.
Couldn't have said it better myself. So thanks for joining us on this incredible journey, everyone. Keep those questions coming, keep exploring, and we'll see you on the next deep dive.
See them? Bye.